Hi. Hi. Check.
हेलो। आवाज़ आ रहा है भैया? थोड़ा सा इसका बढ़ाना पड़ेगा
हाँ, इतना नहीं थोड़ा कम। हाँ।
Yeah, I didn't need it. Yeah, hello everyone. Nice to see all of you. Yeah, so yeah, some of you I've met before. I'm Meela ma'am again, and we are just waiting for our special guests to come soon. They're all saying that because it's rainy, so there's more traffic. So yeah, so how was GMRT? Let's ask the kids. I mean, I know there was rain, but beyond that, what did you get out of it?
We got information, ma'am.
You got information? Okay.
We gained a lot of information about radio telescopes and how they function.
So they were able to explain to you about radio telescopes? Yeah. Okay. Yeah. So what did you?
I got to know about a lot of many other things. We got a lot of information. We learned on working of antennas, how they work.
Okay. Great.
Like it was very interesting to know the practical use of these telescopes and how they affect us in our daily lives also.
So you want to say a little bit more? Just stand up for a minute.
Like uh,
Yeah.
like radio telescopes, we observed that there was nothing within a lot of radius. So we came to know that even our like mobile phones, the waves released, they can affect the telescope, and like we got to know about the working. So it was very interesting to see it practically.
So yeah. So in fact, they told all of you to shut off the mobile phones, right? Yeah. So in fact, that's one of the reasons that some of you may have come with us earlier to Aries Observatory. Anybody here has come to Aries Observatory? Okay, you came last, yeah. So, but because it's monsoon, a lot of the optical telescopes are shut at this time. So they actually cannot even open it just to accommodate us, even because they can't get any moisture on the telescopes. So that's why we had to choose a radio telescope, which is not affected the same way. Yeah. Okay. So, uh, anybody else want to add anything about GMRT? Okay.
I was surprised to know a lot of new things. And they told that there was a AC kind of air conditioning room. We went inside that. They told the air conditioning room was for cooling down the telescope when it gets overheated.
Yeah. So they did take you to the telescope, the AC room. Okay. And they showed. Did you go to a room where they showed some computer downloading the data? Okay. So let's see what you would like to add.
it uh, it gave a lot of information that it shows how much progress India has made as uh, as a full country. It also shows that we are not some poor country with kachra everywhere or
Or even if we have kachra everywhere, we are able to also do very good technologically.
or a faltu disposal country with beggars everywhere.
So yeah, so definitely we have made great strides in astronomy and astrophysics, and GMRT especially has come out with a lot of discoveries and all that. So, would you like to add something about GMRT? Or did you?
Hi, yeah, it was actually a good experience. I got to know many new things. It was also beautiful. It was also beautiful to see the huge like radio telescopes, and I'm proud that our country has the largest meter wave radio telescope.
And as they told you, the telescopes are actually, you saw some antennas, right? But actually they're spread out over a large distance, which makes it a large radius telescope, right? Okay, so who knows where you're going tomorrow? Okay, somebody who hasn't answered.
We are going to the astrophysics laboratory.
Yeah. So, okay. Anybody else wants to guess where we're going? Okay. Not guess, you might know.
Ayuga.
Do you know what it stands for?
I know.
Okay, so anybody knows what IUCA stands for? Okay. Let's come to you.
Inter-University Center for Astrophysics and Astronomy.
Great. So he's absolutely right. I'm not even sure my colleagues know. Ranadip, do you, do you know? Okay, but in IUCA, and I'm sharing this because of one of our special guests today is, a professor from IUCA, and, Dr. Debarati Chatterjee is, in fact, she's heading the gravitational wave astronomy there. So IUCA, for any of you kids who wants to go into astronomy as a career, you might want to, but you're too young to decide that, but you guys might be, yeah. So, career-wise, IUCA is one of the, really good places because it's research and education. So, IUCA encourages people to learn about research and education, and today we have Dr. Chatterjee, who's in gravitational wave astronomy, and we also have Mr. Tushar Purohit, who's a astronomy educator there. So today we'll meet two of them, and like I said, some of them are delayed because of the rain, but it'll be great to meet them. Okay, so anybody knows what is gravitational wave astronomy? Okay, so let's see what you have to share.
So if we throw back to 1915 to 1917, when the time of Albert Einstein, so he said that the universe, based on gravity in space and time, is a fabric, and those ripples are which are caused by pulsars, black holes, and uh, strong galactic gravitational events are called gravitational waves. It it causes ripples, but and they travel at the speed of light, but they are very small compared to what is shown in diagram or in videos. So every time space and time is getting tinily stretched and squeezed.
So he's absolutely correct. But here's the thing. There are some new kinds of astronomy and new kinds of any science that is only happening because technology is progressing so much. So, like he said, Ranadip, why did we not hear of gravitational wave astronomy 10 years back? I'll, so, yeah, it's technology. So same with JWST, but gravitational wave astronomy, the only reason it's happening now, see, like he said, gravity, changes in gravitational field are too tiny. They can't be measured. They can't be measured with any instruments we have. The only thing is they can be measured now because we have good enough mirrors. This whole thing has to be in a vacuum chamber that is 8 kilometers long. So, imagine if you have traffic running, that's going to affect it. So we have to have good enough technology and mirrors and systems that we can actually measure these things. So same reason with JWST, with new telescopes that are going, main thing that has changed is the technology. So we are able to, get further with it. And so here is one of Tushar. I was just telling them about gravitational wave astronomy. Okay, so I'm interacting informally till our other guests because did you also face the rain? Yeah. Okay. Okay, so we'll introduce you to all the guests, and this is Mr. Tushar Purohit, who's an astronomy educator at IUCA, where you will all visit tomorrow. Okay, so you want to come up and okay. So informally, I was telling them that IUCA is a great place because it's does astronomy research as well as education, and some of them said they would be interested in astronomy careers. So yeah. So now let me ask a few of you while we're still waiting, who's excited about, what did you feel about doing NAC? What excited you about taking part in NAC? I'm sure a lot of you have answers, so let's take a few answers, okay?
My brother was participating. He said that it's a great opportunity, so I also participated.
Who said it's a great opportunity?
My cousin brother.
Okay. And your brother has participated, cousin brother has participated before? Yeah. So.
Like, I have a lot of interest in seeing telescopes and seeing the planets by telescopes. One of my sister has a telescope, and I also want to become an astronaut when I grow up. So my father found out about NAC, and I was just very keen to participate there.
So you want to be an astronomer when you grow up? Okay. You want to be an astronaut? So let me ask you this. She might know the answer. What's the difference between astronomer and astronaut? Okay, everybody should know. All the kids should know this answer, right? Okay, see, I'm an astronomer. Tushar is an astronomer. Have you been called an astronaut before? I have been called. Okay, but I'm not an astronaut. Okay, so why am I not an astronaut? Okay, let's see.
So an astronaut is like a person who goes to space and does research there. They
That's
like,
right.
but astronaut like stays on Earth
That's right.
and they like research there.
That's exactly the right answer. Anybody else? Yeah. Okay, you know all the answers. Anybody else?
Actually, astronomers go to space, and the astronauts go to space, and astronomers live on Earth, and they do some research on it.
So, that's right. So the difference is. You want to answer?
An astronomer is a person that looks through telescopes from Earth to the space, while an astronaut goes to space to research there only.
That's right. So as you can see, astronomers stay on space. Stay on Earth and do research. So there can be somebody like me who's just interested in research, and maybe you go through a different career pathway. You go through BSc in sciences. You go through PhD. Astronauts go to space, which means they have to be very physically fit. They also have to have pilot experience or flying experience. So most astronauts come from Air Force and Air Force and pilot degrees. So in fact, all the astronauts that have been chosen by India for what is the mission that will come up that they're going for? Gaganyaan. So they are all from Air Force background actually. So it's a whole different pathway. So if you want to be an astronaut, who wants to be an astronaut? Yeah. So that's because you want to go to space, right? So yeah, whoever wants to be an astronaut, that's also an interesting pathway, but it's very difficult because you also have to show that you're very physically fit, so you have to, train yourself for that. Yeah. Okay, so that's not the only confusion. The other confusion is astronomer and astrologer. Who knows the difference? Okay, you've answered one question. Anybody else? How about you? You want to answer? No, okay. This is a very easy answer. Okay. Okay, how about one of the teachers? Would anybody like to answer this? Ma'am? An astrologer.
Astrologer is those who tell about the time, how it is, whether it depends upon the person's star and other things. No, they are called astrologer.
So basically, yeah.
Astronomy is basically pure science. It studies everything scientifically in the universe, while astrology is basically the superstitious beliefs and the thinking of people based on the movement of the stars in the sky.
So that's probably also correct, but I'll only place it like that both of them study the star and planet positions and with great accuracy, but the way astrologers use it to interpret what effects it might have on life, whereas astronomers don't think of it that way. They just worry about what is the science that governs the motion of the planets. But yeah, both of them look at planets and stars, and both do it with great accuracy. In fact, from the times of Jantar Mantar and ancient times, we know that astrologers have done identifications with great accuracy. Okay, so any other questions anybody has about astronomy? Okay. We no, because we don't have the people here. Yeah, we can't start. No, we can do we ask Gautam if you want to shortlist Facebook or videos? Okay. So again, yeah, we'll just wait a bit more for our guests to come. Let's see what they say. Dr. Debarati Chatterjee is coming. Okay, anybody else want to share your NSC experience? Okay, why did you do an NSC? That's the question. Okay, so let's take a couple of answers. Why did you participate in NSC?
I wanted to really know more about space and astronomy, and it was one of the first few competitions that I came across about space. I wanted to participate in it, and I thought it would be really insightful.
Very good. Good answer. Yeah.
I have I have keen interest in astronomy. I wouldn't choose it as a career, but I do keep interest in night sky especially. I love to see the planets, the stars, and the different constellations. So that I found out about NSC in fifth. I did give a try in fifth, however, I wasn't able to achieve something. In seventh last year, I did achieve the second rank, so I'm very grateful for NSC, and I'm also grateful that my hard work paid off in NSC.
That's wonderful. Congratulations. But like you both said, okay, she's going to add to it. Okay, we want all the kids to answer this question. Why did you participate in NSC?
For the last two, for the past 2 years, my brother participated in NAC. I just listened I just learned when he was studying. That kindled my curiosity to participate in NAC.
So what, your brother also participated in NSC?
Yes.
Okay. Okay. So what was your experience in NSC?
I've seen movies where telescopes are used to study the night sky, and I wanted to do it once. And I learned that NAC is where we learn about the planets and the stars. So I participated in NAC to know about the solar system.
Yeah, that's great.
I watched a movie Interstellar and that really piqued my interest. So, but I know that a career as an astronaut would be really hard. So, as a hobby, I would want to pursue astronomy. First, I went through the textbooks and stuff, but then I wanted to go beyond that. So, then I came across NAC and that really helped me a lot. This is my first time participating, and I got a position. So I'm very happy about it.
So yeah, congratulations. And again, all of you sitting here today obviously got a position in NSC, and congratulations to all of you. But I hope the takeaway also is, like you said, no, one of you said that you didn't win in a previous year. So yeah. So basically, it should also be, we shouldn't feel that we only have to win, because we've designed NSC to also be something that you can learn from, and that's why we do webinars and frequent participation, so you can just enjoy learning and not just have to win to succeed, right? Yeah, so because astronomy is not something that you always have in schools, so this is a good chance for you to participate, right? Okay, so they went to GMRT today, but it was very rainy. Okay, so While we are here waiting for our special guests, we have one of our special guests, but we have some more guests who are going to make their way. And Ranadeep, then you'll have to keep an. Okay, yeah, now I know.
So, Dr. Mila, has a lot of work to do, and while we are waiting, so I thought I'll give her some rest and get one of the volunteers, any of the NAC champions, to just come up here and help me run with this mic. Who wants to volunteer? Yeah, just come up. Fastest one. Okay, you would? All right, lovely. What's your name? Leoma, and where are you from? You are from Faridabad NCR. Okay, so Leoma, I want you to go to each one of the NAC winners here, or the NAC champions as we call them, and I want you to ask them a question. The question remains same for everyone, and it should make you really think. Many a times we want to do something, but we do not really know what is the purpose. Why are we doing it? And if you really see in life, your why is the most important thing. Your success in life depends upon the questions that you ask, not on the answers that you have. But today we will have questions and answers, and please treat this as a very important exercise while we are waiting for the other guests. So the question is, if you become a successful, whether astronaut or astronomer or an astrophysicist, whatever that you would want to call it, what is one problem that you see today around us that you would want to solve? You got the question right, Leoma? Can you repeat the question?
The question is basically, if you ever become astronaut, astrophysics, or astronomer, what problem do you see in the world around you that you would like to solve?
Perfect. All yours. You are conducting this event. We are
Sure. Anyone who wants a chance, speak first. Someone?
If I was an astronomer, I would like to invent machines that could look into farther galaxies and into the other galaxies.
Okay. Specifically, which kind of galaxy?
You'll have to drill and get an exact answer. The problem that you are currently seeing, whatever that it may be. Okay? Try to think. And we have lots of opportunities or challenges that we all must need to solve.
I think
You guys will do it.
think for 5 minutes, then I'll come back to you. Anyone else? See the telescopes right now, with no offense, like Hubble and JWST, they are not capable of adapting with all light wavelengths. And suppose if suppose JWST can do a specific range, it won't be able to do the other ranges. Taking another telescope would just be tedious, and it would take too much time in merging and averaging and aiming and whatever that process thing is. So creating lens that is capable for all wavelengths would be very big jump in progress of mankind. How do you plan to do it? Like any specific plans? Like you researched about how anyone else doing that right now? Engineering. What else? I'm not asking what you want to pursue. I'm asking, have you thought of a way to do that? Like any specific research that you have come across? There's time for me to do that. Very good. Have you thought?
One thing I would like to change is that I would invent telescopes that can look farther into the galaxy, because the now telescopes can only look at the other galaxies from out. It cannot go further inside the galaxy and see what other things are in there.
That's nice.
Okay, you want to
Hello. I would like to add something. There are the couple of telescopes which are observing outside our galaxy. They are discovering a new exoplanet in different galaxies. So we know a little bit more about the galaxy. So this whatever you are thinking, it's beyond that. Okay. And whatever the observable universe we are talking about, its limit for a 3.5 billion light years. So calculate how many years and how many kilometers you are observing. So all these telescopes are capable to observe much more than whatever you are thinking. So we can discover the many more supernovas in a different galaxies. Okay. And recently one of the best telescope is started observing a sky. That is Vela Rubin. Okay. So this telescope will show much more details. All right.
Thank you. I know it has been a long day, and all the kids appreciate your answers. But please remember that the problems that we have, are, for example, some of the guests are late today. It is because of the rains, and the rains have caused traffic jam. So how can we solve that? That would be a big help. Then there is help around medicine, there is help around pollution. So all of those things perhaps are the things that you need to look, because if we make our daily lives better, our life would be better. So we would like to get started now, as we have one more guest already here. Dr. Nath is here with us. Thank you very much, sir. So we'll get started, with the program, and I know it has been a very long day for all of you. So let us start the program as the guests join in. All right. Good evening and welcome to the 7th edition of National Astronomy Felicitation Award. You are all the champions, like we said. And I would like you to understand a bit more about the philosophy. Dr. Mila Mitra already shared some bit of it already, but in more detail, she would like to share with you what are we, what do we do, why do we do it, and how does it help you. That is the most important thing. I'm sure all of you have had interaction with Dr. Mila Mitra quite a few times, I would think, and she is someone who is championing the cause here in India, and her availability has been the hallmark of this whole event, which is definitely a path setter for many of you, and it is your opportunity to get inspired and also learn from her what is the way to become great in this particular field of study. To introduce Dr. Mila Mitra, who is the co-founder, academic head, facilitator, mentor, whatever that we can call her is less. She is the person who is fostering your interest in STEM education, and the domain that she has chosen is space. She is an astrophysicist who has worked for more than 20 years at NASA Goddard and NASA AMES on various satellite missions. She is privileged to have worked with the Cosmic Background Explorer project at NASA, which even won a Nobel Prize. That is a tremendous achievement that she has. She has been invited as a speaker at conferences such as the Annual Astronomy and Aeronautics Conference in Brazil, Global Hands-on Universe and IOE Shaw Conference. She is a member of Norcell Science at Leeds, UK. In India, she has been a very active member as a science communicator and as a coordinator for projects such as the International Asteroid Search Campaign, which I'm sure many of you may also have attended. If not, you can have the opportunity whenever it is next due. And she frequently appears on media as a space expert. We are privileged to have Dr. Mila Mitra here with us, and I would like to welcome Dr. Mila Mitra on stage.
Again, welcome everyone, and very pleased to see all of you here today. And for Dr. Professor Nath and our other guests, today we are celebrating National Astronomy Challenge, which you might have heard of other Olympiads, but what we do here is it's the preceding level. So we hold our challenge from grades all the way from grades 4th to grade 9th, so that kids get a chance to actually dabble in astronomy and find out more before they have to face International Astronomy Olympiad or National Astronomy Olympiad. So today again we are celebrating all the champions that are here that have got merit positions in the National Astronomy Challenge. So before we go ahead, and we have our special guests with us who will also interact with you, but I'm going to tell you a little bit more about STEM and space and what we do and what is our objective. So STEM and space, from the name STEM, who knows what STEM stands for? Okay, one of you shout it out. That's right. So it's not just, it is also, of course, a part of a plant, but that's not what we're talking about. We're talking about STEM, and it's not just science, technology, engineering, math, it's integrating all of them. And so with that, STEM and space, there are many people who are doing astronomy and space education, and that's a great thing because we do need, something beyond our physics, chemistry, math. So astronomy is a great way to integrate all of them, but we have actually reimagined astronomy as not just education, but as engagement. So let me tell you what we mean by engagement. Okay, so we have, we have people now who are very excited about space. Each of you here is excited about space. Who saw the Chandrayaan-3 landing? Okay, not more, I thought everybody, right? And I'll tell you what, I was actually on a television channel, as some of my guests here might be also, and there even the excitement was so much that people came with dholak to the studio and they started playing dholak and they distributed mithai in the studio. So we have people now in India who are so excited about Chandrayaan-3, but does it translate to what we know about astronomy and what we know about space? Okay, so the critical question is, and this is not just, I'm going to talk about what our vision is, and this vision is shared by all of us at STEM and Space, and I'd like to share, this is also the vision of Mr. Gautam Agawari, who is with us here today. And so the thing we want to deal with is, people are inspired, but how do we translate it into becoming a scientific habit for students? Okay, so reimagining. You all might ask the question, how did we land on the moon? No, wow, we landed on the moon. Anybody knows what International Day we celebrated on 20th July? Okay, shout it out. Can you hear? Okay, that's right. International Moon Day, which celebrates the successful landing of the Apollo 11 mission, which was the first mission where Neil Armstrong and Buzz Aldrin walked on the moon. So we are excited about it. But do you then ask, how did they reach the moon? Or even did you ask, how did they reach the moon in 4 days, whereas Chandrayaan took 3 months? So, because these are different strategies. So there's a lot to learn from this kind of question and this kind of inspiration. So we have an untapped advantage because our space industry is doing really well. We already have a large momentum with Chandrayaan, Gaganyaan, and we had the first private rocket launch last week. And so, the space industry is going to really shoot up. And so we have, so all of you here, by the time you grow up, you'll have a lot of opportunities in the space industry. So, but what do we lack? We lack a scalable engagement. We don't have enough astronomy educators or resources. We don't have products that are in daily life. So, and also, do you ask, I know all of you here are interested in astronomy, but is it part of your daily life? Like, me and my colleagues might be going to astronomy websites every day, but do you? So let's see, how do we take it also to the heartland of India and not just the tier A cities? So what worked in the West? Now space is part of the culture. So, they've made it accessible. There are visitor centers, science centers. You've all heard of Kennedy Space Center. You've all heard of, NASA, where they're all very open to outreach and to visitors. You make it part of regular life. Of course, even here it's coming now, but do we have toys? Do we have merchandise? In the West, this is all a big part of making space culture very popular. Then we have to make it sustainable, because we have to have a way that we don't just pay educators, but we have to have a way that we make education, space education, sustainable. So far, traditional science education, and many of your teachers here, and you teach physics, chemistry, math, and of course now STEM is also a part of it, but still students are, oftentimes not these students here, because they're obviously interested in STEM, but there are many students who say, I don't want to do physics, it's too boring, too dry, and too intimidating. And so there are now astronomy clubs, and which is exciting, but it's hard to sustain, because it's expensive, because it's not a part of the curriculum, so it's expensive to maintain it. How do we do it again in smaller towns? So the advantages are, it's many schools do one-time workshops, but how can we do it so that it's a regular part of curriculum or education? Okay, so the way we have thought of it is to make it a little different than just education. We've thought of a way to make it engagement. Anybody here who has joined our Spacetopia platform? Okay, so some of you, great. So many of you, and I hope at the end of it, more of you will. So we have now a platform which is not just for kids. We have a part that is for kids. We have a part that's for educators. And we also have products. And now all of this is at the engagement level, which means it's edutainment. It's not just plain learning. It's through engaging ways. So we also have it for not just kids. We have it for educators. So our model is that we are providing resources that any educator anywhere can just run the programs. And we also have products. We are making a lot of comics, a lot of books. Most of the things here, like videos and comics and books and merchandise, are created by us in-house. Okay, so this is our Spacetopia for kids. We have interactive comics and e-books. We have grade appropriate all the way from grade 2nd. All the way from grade 2nd to grade 10th. We often do live DIYs where you can do projects with us. We have interactions with experts. So, we think of it as an entertainment platform where you log in and do things with us. We also want to enable educators, because many of you here are science teachers, but you may not know how to conduct astronomy courses. So we've already designed a plug and play curriculum, which means that you can just, if you want to teach about the solar system or about exoplanets, like Tushar sir was saying, you can just go and play that course, and there's an activity, you can run it. So it's all very easy to use, and we are creating it so any science teacher can just run it. Okay, so this is how we enable it. We are doing it for schools, for retired educators, for activity centers. And the features are, it's got a user-friendly interface, and we do try to teach strong NEP-aligned, grade-appropriate content for each grade. And each curriculum starts with, what will you learn today, like lesson objectives. And so it's easy for teachers to take it ahead. And through this, we also want to encourage we want to encourage science entrepreneurship, educational entrepreneurship, so anybody can become a space educator. Okay, so we have a lot of comics. Do we have any here today? But we don't have it here physically. But we have many comics. Some of you might have got our space career books. Do you have that? Anybody has our space career books? So through that, see, many of you ask, how do I become an astronomer? How do I become an astronaut? Tell me, who knows any other careers in space? What are the other careers? Just stand up and shout out a few of them to me. Okay. Anybody? Rohit, what did she say? Yeah? Yeah, engineer, space engineer, rocket engineer, yeah? What? That's right, and sir here is, Professor Nath here is an expert in astrobiology, and he will tell us more about that. What? Yeah, that's right. Okay, cryogenic engineer, wonderful. Okay, so now, so great you all, are learning about some new technologies and new career paths. Now I'll tell you something. Is there anybody who's interested in gardening? Okay, anybody interested in food and cooking? Okay, so now you'll say that I'm interested in food and cooking, but how do I take it to be a career? So now it's all interdisciplinary. So there are, you get a career in how do you grow plants, food in ISS? How will you grow it in greenhouses in other planets? If you're a lawyer, you can be a space lawyer. If you're a gardener, you can look into space food. If you're a doctor, you can be a space doctor. So you just combine your knowledge, your specialization, with your knowledge of how it works in space, which is very different. So you just have to combine these things. So we have a book on space careers that is very popular, but we also have many other books, including one on, with Sonalika Publishers on Gateway of Wonders, which is about auroras. We have one on telescopes, and we have some very new books that are coming out called, this is the pointer part, right? Yeah. Okay, so we have some very new books for very young students also called The Sky Above Us, which are stories of Sia, a little girl, and Glitch, a robot, a flying robot. And we use these characters to take us through all kinds of different stories about the sun, about the sky, about moon phases. So we are designing all these books. So as you can see, we are going beyond, we're not just going into education, but thinking of various ways to encourage students to get into astronomy without feeling it's too technical and too boring. Okay, so these are some of our products. We have games, we have models. Okay, so this is our engagement for kids, for younger kids. Like I said, it's story and character based, and you get to know some of the characters, so you look forward to their quirky things, what they do in different stories. And for the more advanced students, we have experiential learning, we have interactive dialogues. So we have books that have QR codes, and you can get into it and solve games or puzzles that will help you learn that particular section. Okay, so what is our ultimate vision? It's to empower and make it a space-ready nation. Okay, so we, as a company, as an organization, STEM and Space, do many astronomy outreach events, and we have done National Science Day, National Space Day, which is coming up again in August. We have Aryabhatta, anniversary of ISRO, World Space Week, Asteroid Day, and of course, any celestial events like eclipses. So We were privileged to also be a part of, selected by IAU to do a teacher's training. We got funding for this project. We did a teacher's training at Aries Observatory using our Spacetopia platform, where students could understand through our demonstrations how to run these programs. And here you see some of these teachers are excited to do the activities with us. Okay, so some of you have joined Spacetopia Kids, so all of you are welcome to find out more about it. And let's do a quick walkthrough. Just see if you can play.
Spacetopia is a mission driven by academicians, researchers, and educators with one belief: every curious child deserves access to space. Our goal is simple: make astronomy accessible, engaging, and meaningful. The child's journey begins the moment you log in to Spacetopia and enter the dashboard, where a universe of possibilities opens up through our carefully designed menu. Explore our space comics. Watch immersive videos and learn at your own pace through certificate courses. Submit your work, do quizzes and earn stars and rewards along the way. Participate in fun DIY sessions and learn to build like an engineer and think like a scientist. And when curiosity strikes, head to Ask an Astronomer. Record or type your question, and our experts answer the top ones every month. And learning doesn't stop there. Play daily quizzes, spin the cosmic wheel, climb the leaderboard, and win exciting rewards. Join our monthly live sessions and mega quizzes to interact directly with space mentors and walk away with cool prizes and certificates. And this is where learning meets collecting. Visit the Spacetopia Marketplace, your one-stop shop for space merchandise. From stickers and puzzle boxes to astronomy kits and more, there's something for every explorer. Spacetopia is a
So yeah, please visit this platform, Spacetopia. It's very exciting, and with that, I would again like to congratulate all of you who are here today, but we will have that moment a little later on. And please join us. We have regular webinars and regular sessions. So thank you all of you. Thanks to all of you for listening to me speak about Spacetopia. And all of you are welcome to join us on this platform. And keep staying interested and exploring space. Thank you. Okay. Thank you.
Thank you, Dr. Mila. This was very, very inspiring, and my takeaway, which I would like to share with you, and perhaps that could be a takeaway for all of you young stars, is that stars do not compete, they simply shine. Like Dr. Mila Mitra, so can you shine too. All right, so I now invite our next guest for the evening, very, very illustrious Dr. Bimlendu Nath, who has made it here to be with you, to be an example that you perhaps would like to emulate. And just a few words, if I could, with your permission, introduce yourself, sir. Dr. Nath is an educator, mentor, researcher, and principal investigator of many nationally and internationally funded research projects. He is an author of many research articles, reviews, and book chapters with an experience of more than 30 years in higher education. He holds key positions including honorary emeritus professor at Savitribai Phule Pune University. Currently, he is director of the MIE SPPU Institute of Higher Education, Doha, Qatar, in collaboration with Pune University. His academic and research area is environmental stress-induced adaptive processes. He is also an adjunct professor, Norsel Institute Education and Research Academy, Leeds, United Kingdom. As I see him, I don't just see him as an illustrious achiever, but as someone who is full of humility. While I was trying to introduce him, he was saying, no, don't do that. So here you are, Dr. Vimlendu Nath. Certainly, sir.
Thank you so much for all the kind words, and I do not know all those things. My credentials reflect. I don't know. Anyway, when first of all, thank you very much, all of you, the organizer, and especially Dr. Minamitra, because she was instrumental to bring me here, and I cannot say no when a request comes from somebody who has spent gazing the stars and from NASA, and we interact in other matters also regarding higher educations and other educations of space biology, space science. Now, I started from my lab in Pune University today, and I know that okay, I reach home and then I freshen up and come back. So all my calculation went wrong. I started at 5 o'clock, and actually my son was driving. I trust him more than Uber and other, these hired vehicles. Then, because he compete with the Google always, the map showing 1 hour, that becomes 1.5 hour, 2 hours. Then I had to write small message to her that I won't be able to make it by 7. I was feeling very bad because I'm very punctual. That's what the reputation I have in Pune University. But anyway, she said, okay, you come. No problem, we'll wait for, obviously they will wait for me. And then I was asking my son what to do. He was driving, the four-wheeler, so you have less, the sort of maneuvering skill in a Pune like, traffic jam. So what happened? The Google showing some map. He said, no, I'll ignore it. And then, he rerouted himself. And then the time reduced that I can reach by 7. Again, something happened. He said, I'm rerouting. So that's what, and I was preparing what to tell to the students, young students. I was feeling very nervous because you all are achievers, okay, at this age. I was not an achiever at your age. So first of all, let us give a big hand to all the young achievers and fertile minds here. And it's an honor to be with you all. Okay, I spent time with many, the celebrated academicians, scientists, astronomers, and whatnot. But to be with, I had less opportunity to meet the students who are young achievers. And thank you, organizers, for giving me this opportunity. So I was thinking what to tell what to tell to you because I know that obviously I am a invited guest, so I have to say something, speak something about something. Of course, about the higher education and so on. So every time I was selecting a topic, okay, during this, grueling, the journey, from my residence to here, and I was saying, no, this will be very boring for the young kid and also for the adults. So let me tell you, I grew up with space, stars, and all that. My brother is an astrophysicist, astronomer, Professor Biman Nath, and he used to wake us up, in Assam, my homeland. So, okay, it's 2 o'clock, get up. There's no rain, winter time only. we used to go to the hillock and the mountain top, and then we used to, at that time, he used to drag me and my sister see the Jupiter, and he had his one telescope. He was studying at the time in school only. So I was introduced to stars and everything from my childhood and his childhood. But later on, we diversified. I started exploring more about the microcosm. So I spent the rest of my life with the microscope till now. I spend almost 1 hour, and he spends life with his time with the telescope. But both of us, we sometime we discuss about something common theme. Let me tell you my current research interest and my PhD student what they do, and you can connect the dots with the space science and biology. And space biology, which is not very well known now or very popular. You know that there's a tide. Do you know what is the tide? Tide, those who are in the coastal city, in the ocean, there is a tide. And do you know there is a connection between when the full moon and there's so see, this is what called a lunar rhythm. So something is happening on the earth, and that is a lunar rhythm. And there are lots of marine organisms, even the freshwater fish, they have a clock which exactly matches to the lunar rhythm. And this lunar rhythm repeats. Rhythm means anything that repeats at a fixed interval. Then otherwise it becomes arrhythmic or noise. So every time it repeats, whenever it is the full moon, okay, and something like that, we call it lunar rhythm. There are something which is called circadian rhythm. Like suppose hypothetically, it should not happen. It's like the storytelling, horror story. We are stuck up here. Next 4 days, but assured that okay, after 4 days we'll be released. There are everything is there, food and everything, but we have to sit down here for some kind of a kind of a calamities or whatever. Okay, don't worry, it won't happen. Just imagine. But at some time you will start asking, the organizers, I'm feeling hungry. Who tells you? There's a body clock. At some time you feel sleepy. Who tells you? Without any watch. So there's a clock inside. And that clock exactly matches with the day and night rhythm of the earth movement. And this is called circadian rhythm. Anything that is a cycle of 24 hour, 12 hour, 12 hour, we call circadian. Lunar rhythm. Do you get mango in the winter time, naturally, because you can preserve it artificially, there's an annular rhythm. At a season it comes. It repeats once in a year. So these rhythms, where the plants and animals matches with the cosmic, the events, and that's an area which is coming up in the space biology, is called space chronobiology. And there's a lots of future because many of our diseases, insomnia, lots of arrhythmic, the function of the body, it gets, because of this arrhythmicity of the internal, the solar system or the cosmic whatever, the interstellar, whatever things are happening, and many things are unknown, and we get disease. We do not get sleep because I was in Norway for 1 month, and I decided this is not the place for me because I reached there in the afternoon time, nice sunset. It's a Trondheim, not at Oslo, and it's a North Sea Stars. And from my room, I can see the church and the beautiful sun, and I slept. After 8 hours, I woke up. It's still the daytime. I said, "What is happening?" It's PM. And then I asked, "Okay, what time do you get married?" Well, I know you have to wait for another 5 months or 6 months. Then it is. Then my whole physiology got disturbed. Do you know? So this type of arrhythmicity, the rhythm alteration is coming up now, which has to be connected to the space biology or the cosmic events. This is another career, the opportunity I would like to tell you. Secondly, let me tell you, when I was getting out of my house, my cousin brother, he was actually asking Alexa to close the door when I leave. My nephew is busy with the chat GPT to finish the assignment. And my uncle, who is staying with me, he's finally agreed to use a chatbot app for the health app to monitor his local health. So without knowing, something installed in his mobile which is run by AI. We are gradually, somebody asks you that after 2030 or when there be change, the third decade of this, the century will be, all of you know that, will be dominated by AI. And STEM education is facing a challenge to find out a strategy in the classroom or outside the classroom to handle the curricula or the pedagogy or the how to keep up with the advancement of the AI, which is integrated in our daily life. Let me just give you an example. I have seen many students or even adults, if you ask them, of course they are Gen Z, if you ask them that, this is a small, can you calculate it? What is the add up, how much money has been deposited? So 1 plus 1, it's not a joke, really I've seen 1 plus 1, 2, not sure. Let me check with the calculator. So this type of things are happening. I don't want that you all become a slave of AI. Remember, when I was coming, I was ignoring which has been, the Google map is showing, because I know it is not correct. With my experience, I took the risk and I could reach at least at 7:30. So remember, AI is a tool. AI is a tool. It will remain as a tool. And STEM education, whatever you people are pursuing, like I think all of you are science students, okay? All of you are pursuing, that's the foundation. So don't allow your brain to overpowered by AI. Use it, but you should be the boss. Secondly, uh, let me just end with a funny story. I can be a little informal. I need 1 or 2 volunteers. Are you ready? Yeah, he's. No, be there only. Just tell your name. Hmm? How do you spell? Okay, Kush. Okay. And somebody, yes, your name? Huh? Leoma. Okay. Kush Leoma. Uh, so imagine that I'm a very celebrated scientist, which I'm not. Okay. And I have been invited. And organizers are ready to wait till 10 o'clock, even the audience. Okay, there are people who have been not allowed to come to meet Dr. Nath. He is a celebrity, just missed Nobel Prize. And he was invited here. And then nobody knows what he's going to do. Then he asked all these young achievers, like champions, can you draw Chandrayaan 3? Just make a sketch that is landing. Okay, and the best sketch will be given a prize. And so it is morning time, in the evening time function it will be given. Let's say in the morning you will come, evening also I'm supposed to come. You are all so frustrated that this person comes and no question, no interaction, asked to sketch like a school kid. Chandrayaan, we have come through all this, the challenge championship and just drawing a sketch. Coach decided, he was very, and he's very good in making, okay, hypothetical, maybe you are, okay, um, that I'll make a sketch and Leoma said, wonderful, this is perfect. and let us, they go in the lunch time and nearby shop, photocopy it. How many of you are here? 35, 40? No. We make a photocopy, keep in front of us. When this Dr. Nath will come and this select the best one. This is story number 1. Another story, but I mean the case number 1, and the another alternative case. Then Newman said, forget about it. Who bothers for such type of prizes? We are getting prizes given by the STEM and space. That's more important. And he's asking for a prize for making a sketch of like Chandrayaan-3. Forget about it. Newman said, we will draw whatever. It may look a rocket, it may look a plane, okay, whatever it may be. We'll just draw it. We won't get a prize, fine. And you also draw something like that, or maybe you get the first prize. Case number 2. Case number 2. Let us first. I came, I found Leoma, show your. Do you think it's a Chandrayaan? It is not not even it is a vehicle. What you have drawn, I have not expected. Yours? Yours? Oh, look, this should be like this. Coach is the first prize. Case number 1. I take Kush. Beautiful, beautiful. Okay, you should be an artist. Why you become a space scientist? Second one, okay, yours. Oh my God, let me compare. You are also same. It's all photocopy. Okay, like yours, same. I'm confused. What is happening? Can I select the best? Can I select the best? No. And that's what the Darwin said. The survival of the fittest, but there should be variation. So if there is no variation, you cannot select the best. And nature select the best. Right? And at other time, like you survived, okay, because you are the best. So what is important in evolution? Variation. There should be variation. And STEM education plus AI gives you this opportunity. Each one has to instruct the AI to what you want to do. So each one will have a different product. And each one will have a variant. And then you will survive in the next, after, the next decade and so on. So that's the message to all of you, that use this as a tool and use your brain. And 2 minutes more. Lamarck. Before Darwin, Lamarck was also. By the way, Lamarck was interested to be stars and everything. And he had his theory, but all those things were discarded. But one of the Lamarckian view is that theory of use and disuse. If you do not use certain parts of the body, it becomes, vestigial. And generation after generation, it will be vestigial. This is a vestigial organ which is redundant. When I need a calculator to assure myself 1 plus 1 is 2, 4 divided by 2 is not 3, 2, that means I always need, then I become totally slave of a machine, a device, that part of brain becomes, vestigial. If that happens, human race has a problem. And never allow that to happen. Always, use your brain and then check with your AI. AI empowered device, what I'm saying, or any app or any software. So use your own creativity, and that's what those who are, in the STEM education, I want to caution you that what is going to happen, and you can safeguard yourself for maximum use of your brain. Thank you very much. I hope I have not bored you. Thank you so much.
Thank you, Dr. Bimlindu Nath. And the key takeaway here, and I'm sure you all would have picked it also, reroute as many times, but reach the destination. Right? Yes? There should be energy in this room. There's youngsters, isn't it? And who can stop you from reaching the destination? Nobody. Nobody, not even yourself. Okay? So that's lovely. And of course, the second thing which was very, very evident, I would say the sky as well as Dr. Nath teach us humility, wonder, and gratitude is something that we should always be having. Always be having. That is the hallmark of any scientist. All right, so we continue with our next speaker, Professor Debarti Chatterjee. Professor Chatterjee is a professor at IUCAA, and it was quizzed here, the full form, and I will repeat it if some of you might have forgotten. Inter-University Center for Astronomy and Astrophysics. And she is also a theoretical astrophysicist. She is chair of education and public outreach at LIGO India, gravitational wave astronomy. She is a well-known science communicator who gives frequent public talks and radio interviews. She is an ambassador for diversity, equity, and inclusion in science. Dr. Chatterjee is also director of Pint of Science India, which brings science talks to the public. I'm really grateful to you that despite all the challenges on the road, you made it here to encourage our youngsters, and the kind of energy that I already see would be very, very contagious, I'm very, very sure. Here you are, Professor.
Thank you very much. Thank you. It was indeed a challenge to get here today, but I'm very happy to be here. Thank you very much to STEM and Space for giving me the opportunity yet once again to interact with all of you. Do we have some slides that we can show? Sorry for the technical delays. So, how many of you have heard about black holes? Oh, that's a very good number. How many of you have heard of neutron stars? Also a good number, I'm surprised, okay. I hadn't heard about neutron stars before I thought of working on them. How many of you have heard about LIGO India? Not so many, okay. So I will tell you today the story of LIGO India and why we should be very proud of it, and what is going on here in India, which is very exciting and is going to bring us closer to demystifying the secrets of space. So here is actually a picture of LIGO India on the right-hand side, and I will tell you what it is going to do for us. So how many of you have already looked at the night sky through a telescope? Okay, that could be better actually. I think you all should really go out there and try. If you are visiting Ayuka, I don't know if you had a chance to look at through a telescope, but here you see, so these are some fantastic photographs. So astrophotography is a wonderful hobby, right? So these are photographs, as you can see, from all corners of the world, which were sent during an astrophotography contest that was organized by the Office of Astronomy and Education. And here you see that, I mean, I think this is something we all share, is the, the fascination for the night sky, right? And you all will agree that there are these billions of stars that we see, like the Milky Way. When we go to outside the city limits, we can already see the beautiful night sky. But what if I tell you that this visible sky, these stars, are actually a very tiny fraction of what the universe offers us? So light, I mean, in general, radiation can be across many different frequencies. So many of you have already had X-rays, and you may have heard of infrared, what we are using in remote controls, and radio waves and so on. So these are also electromagnetic radiation, just like light, but our eyes can only see this very small fraction of light, okay? Everything else in the universe, so the stars are also emitting radiation in other frequencies, but we are not able to see them. Not only that, here is what scientists think the fraction of how little luminous matter is in the universe. So matter that is emitting radiation. So you add up all these stars and everything, and it is actually less than 0.4% of the entire universe. And most of it is made up of matter which does not emit any light. We think it could be dark matter and dark energy. So most of the universe is actually not observable through a telescope. So how do we observe it? Even if we have the most powerful telescopes, we are not actually seeing most of the universe, right? So here are some examples. So you already said you've heard about black holes and neutron stars. So these objects are actually not emitting radiation. We call them black holes because they don't emit any light, right? So they are black. They don't allow light to escape from them. Similarly, so black holes are extremely compact. So you can imagine crushing the sun to a very few, a small, the size of a room. And neutron stars are of the size of a city like Pune. So you take the sun and you crush it to a very small radius of the size of a city. So that is what is a neutron star. So they are extremely dense objects in the universe. And these objects are formed when normal stars die. So normal stars, what do we mean by normal stars? So all the stars we see, including our sun, so these are burning gases in their interior, but this will not continue forever, and one day they will stop emitting radiation, they will collapse and form these very dark and compact objects. Now the question is, if they don't emit light, how can we even detect them? This is just going to be a fantasy, right? So this is what, this is here a simulation which shows what we think, say a star like our sun. It is burning fuel in its interior, it's glowing like a ball. This is why we see the stars. And at some point, it runs out of fuel, it collapses, and in the center we have these compact objects, okay? Now, there was a wonderful discovery. I think some of you may have heard of Jocelyn Bell. How many of you have heard her name before? Okay, very few. So you should remember her name. So Jocelyn Bell Burnell was a young PhD student working at Cambridge University, and she was looking at radio frequencies through this telescope. So you all had a tour of the GMRT, right? So you have seen these dish antennas. So long back, in 1967, so she observed some very, very periodic signals coming from a certain direction of the sky. And these were rotating like this. So these are objects which are rotating, and they are called pulsars, and we observe these pulses very, very regularly, and that is what she discovered. So at that point, people thought, okay, maybe these are some, emission coming from the sky, or maybe some aliens trying to contact us with radio and so on. But finally, we know that these are actually neutron stars, which are emitting radiation, and we receive these pulses. So these are called pulsars. And today, um, from 1967 to today, we have a lot of different instruments, whether it is on the ground or whether it's a telescope in space. So we can observe these objects like neutron stars, which are emitting in radio, X-ray, so not in the visible range, but we can still observe them with the help of all these telescopes. Many of them are from India, so I have listed the ones in India, so if you have a chance, do visit them. So this one in GMRT you have already visited. This is the Ayuka Giravali Observatory. And this is the Hanley Mace Telescope. And there are also other Indian telescopes like the Himalayan Chandra Telescope, the AstroSat mission. Also, Ayuka took a big part in this AstroSat mission. And these together observe this entire, they scan the sky across these frequencies, and they observe radiation coming from neutron stars. So you see now we have even more beautiful images coming from, we are living in a fantastic time when we have so many space telescopes operating. You must have heard about the James Webb Space Telescope. So these are looking at wonderful objects, and they are even discovering supernovae which were formed way back in the universe, like early universe. So all this is giving us information about the supernova, that explosion at the end of life cycle of stars from which neutron stars are born. So now we have so much of data coming from space telescopes and ground-based telescopes that is enriching our information, our knowledge every day. And so here you can see this wonderful image of a pulsar. So this is actually the pulsar sitting in the center of this nebula. So if you look at this nebula, it's called the Crab Nebula, at different frequencies. So you see X-ray, radio, UV, and so on. Most of the time you can't see through it because there is a lot of dust inside the galaxy. But here you can see in X-ray, X-rays are very powerful, and you can actually see that pulsar, that neutron star sitting in the center of the Crab Nebula. So these are wonderful images, right? And not only that, now, very recently, since 2019 onwards, we even have indirectly taken photographs of a black hole. I think some of you may have heard about this. So these are the first images of a black hole. So of course you will ask me, how can we see a black hole? Because black holes do not allow any light to escape from them. That is correct, but black holes often have, some companion objects nearby, and if that black hole is sucking up radiation from that surrounding object, something like water flowing down a drain, so you will see that glowing gas falling into that, like a glowing gas disk falling into the black hole, and this is what we are observing here. So this is actually a black hole in M87 galaxy, and this is one in the center of our galaxy, the Milky Way. And this was observed in 2022. And with the help of all these different telescopes across the Earth, so together they are called the Event Horizon Telescopes. So some of them are in Chile, Hawaii, South Pole, Arizona, Mexico, from all over the world, and they have processed data for over 10 years, and finally they have come up with this image of the black hole. And not only that, you can see these lines also. So these are polarization lines, which means they can even tell us about the magnetic field around a black hole. So this is amazing. So earlier, I think our, earlier generations, they could never have imagined to have a photograph of a black hole, and today we have that as well. Now going forward, there is another new window of astronomy that opened up very recently. And this came with the idea that Einstein proposed 100 years back. So you may have read about Newton's law, which very nicely explains the gravitational force around us. So any two objects, they are attracting each other with a force. That's what he said when there was an apple falling down from a tree onto the earth, and therefore the earth is attracting the apple. So we know that this law works very well in everyday life, until it doesn't. So when we go to very fast spacecrafts and so on, so Newton's law fails because of at very high velocities and at very strong gravity. So in that case, Albert Einstein proposed the theory of general relativity back in 1915. So he said that it's actually not that simple. Gravity is actually, it can be described as, curvature of the space-time around us. It's kind of mind-baffling to think of this idea that we are all floating in kind of like a web of space-time, but that is the idea. So anything which is massive, so imagine a stretched sheet here and you put a heavy ball and it's going to dent the surface. So something like that, you put the sun and the moon and all of these objects in this web of space-time around us, and that is going to create a dent or a warping of that space-time, and that is what is called gravity, according to Einstein's theory. And this theory also predicted that just like if you shake the surface, or if you throw a stone in water, it will generate ripples. So if there are objects colliding on this space-time, they will also produce gravitational waves. And these gravitational waves will carry information about these dark objects. So this was a fascinating idea because black holes, neutron stars, these are extremely compact and dense objects, which means that they will produce gravitational waves even though we can't see them, with telescopes. So that was a fascinating idea. The only challenge was, where do we go looking for them? So these objects, black holes and neutron stars, they are colliding as well in space. And these gravitational waves are extremely weak, so they pass through everything, and it's extremely hard to detect. So it's like almost like observing a hair moving on the surface of the moon. You need very, very high precision. So that is now the next challenge. So people were hunting for gravitational waves since 100 years. They had built spherical detectors and bar detectors and so on, and people failed and said, okay, almost gave up and said gravitational waves will never be detected. I have actually met people who said that. Until LIGO detectors were built in the US. So these are giant gravitational wave detectors underground. So you can imagine like this, L-shaped, 4 kilometers. So they are huge. And there are 2 of them across the US in Hanford and Livingston, the ones you see here. So this is Livingston and this is Hanford. And there is also another 3 kilometer long detector, L-shaped, called Virgo, and this is in the border of France and Italy. So they devised a new type of object which is going to, like, there is a light beam which moves through it, and if there are gravitational waves passing through it, it is going to change the pattern that you see here, and it is going to allow us to detect gravitational waves. So back in 1974, already these 2 people, Joseph Taylor and Russell Hulse, saw that there were a couple of neutron stars. They were observing these neutron stars and saw that they are coming closer and closer together, almost like spiraling and going down a drain. And they said that this is happening because gravitational waves are being emitted. But this was the first indirect evidence of gravitational waves, and they got the Nobel Prize in 1993, but we were still not directly observing gravitational waves. But then finally it happened. So in 2016, the first time 2 black holes colliding, they were seen in the LIGO detector. So they were the first signal that was seen, and you see it has this typical pattern. It's called a chirp signal. I don't know if you can hear it. Let's see if you can hear it. No. Okay, so it actually sounds like a chirp, like a bird. Whoop, something like that. So that's why it's called a chirp signal. So this is very characteristic of black holes colliding. So this happened, and this was detected. First time ever, gravitational waves were detected, and this also got them the Nobel Prize in 2017. After this, in 2017 again, the first time 2 neutron stars were also seen. Yeah, sure. Yeah, no problem. So they are not pulling each other. So they are basically Yeah. So here, so black holes or neutron stars as well. What happens is they don't collide like cars collide. Like cars have accident, like they go straight head on. What happens? What happens? They approach each other. They kind of there is yeah, you can say there is an effect of attraction as well. And because of that, both start doing a dance around each other. So it's like they go around each other, spiraling. Sorry. No. So they will go around each other, like in a circle, and then coming closer and closer until they merge. So I think maybe here also you saw a little bit like this. Yeah, here you see this black hole. It's a little slower. Like you can see here because they are kind of like bouncing around each other. And here they are. You can see they are spiraling closer and closer. They are losing energy through coming closer and closer. At some point they will merge and form one object. Okay, so that is where that signal comes from. Yeah. So yeah. Sure. Yeah, so actually, it's very fast. So of the order of seconds or milliseconds. Yeah, they are extremely massive, and it happens very quickly. Yeah. Yes, that was detected. It's a challenge. Yeah. So the event happened in 2015, and the announcement was made in February 2016. Yeah, the Nobel Prize. Yeah. Yes. Yeah, good question. That's the thing. So any of these gravitational wave discoveries, we do not see them in a telescope. So that is why gravitational waves is a different window to the universe. We say it's listening to the universe. So we only detect its frequency. So you are asking how do we know it's a black hole? So that's the thing. So we know the behavior of a black hole. So we model it with simulation. And we say okay, if it is like this mass, so it is going to this frequency it is going to show that kind of a signal. And that is why from that we can infer that this was the property of a black hole. Yeah. Yeah, that's true. They don't emit any radiation. But for example, there is no other object. That's what we think. There is no other object which can be more massive than say 3-4 times that of the sun. So if it is an object that is colliding and it has that mass, it must be a black hole. If it is less than 3 solar mass, it could be a neutron star. Yes. So this is the prediction, and then we match it with the observation and try to infer. Yeah. Right. That it is emitting radiation. Yes, exactly. So this is all following Einstein's theory of gravity. And then we see actually today there is an announcement. If you go to the LIGO India website, you'll see that today there is an announcement. We are always testing Einstein's theory as well. Every time we get better and better observations, we test and we find okay, this is still validating the theory. But we are always questioning, and we are always also you can also question that there is some other object which is not a black hole. This is also possible. There are theories which say there are black hole mimickers, and then scientists right now are wondering how to differentiate them from black holes. So there are all these challenges. Yeah. Yeah, so black holes, there are theories of different types of black holes. For example, in the early there were primordial black holes. Then you can have supermassive black holes in the center of galaxy. You can have stellar black holes from dying stars. So we have all these different properties. We also match them with other observations, with other telescopes. So we have some idea that their masses are like and what their properties are like. But then there are also theories which say you could have have, for example, a dark star. There are theories which say there is just a dark matter clumping to form a star, and that could behave like a black hole. So of course, these are always new questions which are popping up, and scientists are just starting. So that is what I'm telling you here. Yeah. This is working. It's echo. So what I was saying is, this is why I'm telling you about this. This is a very nascent and very new field of astronomy. We are just scratching the surface. So you can imagine just 10 years ago, we had the first observation. And I will show you that today we have almost 400 observations. But still, imagine like Galileo's telescope until today. So it's like that. It's a new window which is opened up, and we are now trying to explore what all we can discover from this. Yeah. Okay, so and also soon after in 2017 we also found a collision between two neutron stars. And what was amazing this time, we had a firework seen in radio, in X-ray, in gamma ray, all of these other frequencies as well. And therefore, this is the first beginning of a new era which is called multi-messenger astronomy. So adding gravitational waves and telescopes, now we can observe many properties and understand neutron stars much better. So now this is exactly what I was saying. So starting with only one observation. I told you in 2016 was the first announcement, and in 2026 we just celebrated the 10th anniversary of the first detection. And already this is currently what all we have observed. So more than almost 400 black hole mergers. 400 collisions of black holes and neutron stars. Neutron stars are much less, so these are the number of neutron stars colliding, and these are all black holes. And they are fascinating us because earlier these are electromagnetic, like the ones with telescopes what we have observed. And these numbers are the masses. So we thought earlier that between 3 and 20 times the mass of the sun, that is how massive black holes can be, like these kind of range. But now with LIGO we are discovering 200 times that of the sun. So now there are new questions. How did these massive black holes form? There is a theory which says that you see that arrows, so they point to black holes merging to form another. So now there is a new theory which says that maybe two black holes they merge to form a bigger black hole, and this is how you form bigger and bigger black holes in the universe. Can they split again? Good question. Usually not. Yeah, usually they are growing in size by merging. But of course, they are all interacting. So they could evaporate as well. According to Stephen Hawking's theory, they could also evaporate if they are light enough. So there are all these interesting theories. And now, to tell you about what is the exciting thing happening in India. So you can see here, so currently, so there are all these observatories, like I told you, these L-shaped observatories which are across the world. So the LIGO detectors in the US, the GEO detector just shut down. It was a small detector in Germany, Virgo detector in Italy, and Kagra detector in Japan. It is still not operational, but it is in the collaboration. And now we have LIGO India coming up. And what is LIGO India? So it is an exact replica of the LIGO detectors, but it is coming up here in Maharashtra. So you can see here, so this is the India map, and this is coming up in a place called Hingoli. And Hingoli is here, like not very far away in Maharashtra. You can see me here with some of our outreach team with the cornerstone here of LIGO India. And this is very exciting. And why are we building LIGO India? So the question is that you need, do you know how GPS works? So how do we pinpoint something, a location? When you're driving, how do we pinpoint? So we use actually 3 different satellites, okay? So we need at least 3 satellites to be able to determine the location at a point on Earth. Okay, so we use the same technology. So with 2 LIGO detectors, we can see only like this arc in the sky. But if you put LIGO India here, this localizing the source in the sky will go to a point, which means that now we know exactly where this collision is happening. We can point our telescopes there and we can observe many other things. So LIGO India is the next big thing in gravitational wave astronomy, and it's happening right here in India. So it has already started construction and it should be up and running around 2030. And this is again just the beginning. So I was just talking about the second generation. The first generation LIGO detectors did not observe anything. Second generation is where all this is happening. And now we are already talking about bigger, better detectors. And what are they? So we have proposals called Einstein telescope. So this is a telescope coming up. It is called a telescope, but it's underground. And it is a 10-kilometer triangular telescope, which is coming up in Europe. And Cosmic Explorer is proposed in the US, and this is 20-kilometer long and 40-kilometer. Can you imagine? We have just built 4 kilometers and we were surprised. And now we are talking about 40-kilometer long detectors. And these are extremely challenging. Imagine building a detector which is straight and the Earth is curving, so you have to even correct for that. So these are extremely complicated to design, but we are already working on it. So it will come up in the next 10, 15 years. So by the time you are working, you will be seeing these detectors in action. And in space, so we also have gravitational wave detectors coming up in space. So there is a mission called LISA, which is being launched, and this is this triangular shaped gravitational wave detector, which is already they send the LISA Pathfinder to see how it works. It's working pretty well, so they are going to send the LISA telescope very soon. And not only that, there are also plans from Japan and China, so DESIGO detector, Tianqi, and so on. And India is also designing a detector in space for gravitational waves, and this will be beyond LIGO India. Yeah. Yeah, actually, so these are a different frequency range. So LIGO detectors, they look for higher frequency detectors, and these are going to look in a lower frequency. So they are not going to, because Earth itself, this is one of the reasons we are sending them to space, because Earth itself has vibrations, which is why we build detectors in a quiet place like Hingoli. And already there are seismic noises, there are, even if cars pass, they are going to, affect the gravitational waves. So when you go to lower frequency, you cannot build a detector on Earth. That's why the next big thing is, if you send them to space, you can go to lower frequencies. Okay? And not only that, we are also talking about detectors on the moon. So there are already proposals of where some of them India is also involved. So this one is from Karan Jani. He's of Indian origin, but he's in the US. So the Gravitational Wave Lunar Observatory called GLOC, and it is going to be used for cosmological studies. So this is also designed here, as you can see, here on the moon. Then there is the lunar gravitational wave antenna. So this is also a great idea. They are going to put seismometers directly on the surface of the moon and use the moon as a detector. How cool is that? So that is the LGWA. So this is also being considered now. There's lunar seismic and gravitational wave antenna. So there are many proposals which are coming up, and these are being considered by the different space agencies right now. And yeah. And you already know about the Chandrayaan mission, right? So Chandrayaan also sends something called ILSA, and this lunar module also helps to understand seismic studies of the moon, which tell us, okay, how how good is the moon as a detector. So we can study all these things with Chandrayaan, and therefore we can consider whether or not we want to build something. And not only that, there are also other missions which are being proposed. So ISRO is already considering several proposals, including Daksha mission. So this is actually led by IIT Bombay, some of my colleagues, including Professor Varun Bhalerao. So they are designing some missions which are going to, like LIGO India is going to help in detecting gravitational wave sources, like these collisions in the sky. And Daksha is going to be the Indian eyes on transient skies, which means that if we can localize that collision in space, then Daksha is going to point there, and it is going to get the gamma ray and the X-ray, so all this other information. So this is also under consideration. Yeah, that is an important question. So that is another question, how to build a detector. So they talk about building detectors in the crater or a different design, how to avoid, this kind of there are different, for example, this one, like I told you, this is just going to put like seismometers directly on the surface of the moon. So there it does not matter. If you have asteroids or even moonquakes, you have to correct for it. You have to subtract that out, but you can still use the moon as a detector. But of course, if you're building some structures, then you have to be careful that you are, it is not being bombarded by asteroids or something. So yeah, I think, yeah, I talked about most of it. And GMRT you have also visited. So these are also listening to the hum of the universe. The universe, I mean, we are talking about listening to the universe. So all these collisions, bang, bang, so LIGO is listening to them. But there is actually a background hum, and that is in nanohertz, so very, very low frequency. And this is being detected by the GMRT. So a couple of years back, they announced that they have found evidence of this background hum in the universe as well. So you see that with all these ground-based, space-based, and these radio pulsar timing, like these GMRT type of antennas, we are now exploring this entire universe, this invisible universe that we could not do earlier. Earlier, we were only building bigger and better telescopes, sending them out in space. But now combining all of this, it's a new universe where we cannot see the objects directly, but we can infer from listening to them. So this is a very new and very exciting field of astronomy. It's growing very rapidly. And there is a lot of prospects for students because there are many, many different technological applications here, which is why India is profiting from building this LIGO India detector here on Earth. So you can see here, not only in astronomy, but also laser technology, vacuum, optical, sensor, control system. You need these LIGO detectors are among the most sensitive detectors on Earth. So that's why to build them, you need the most precision technology. And these are being developed in India. So whether you're an engineer, an astronomer, whether you're a theoretical physicist, all of you have a prospect of working in gravitational wave science. And there are many, many opportunities coming up. So yeah, if you want to know more about LIGO India, you can also go to the social media pages, you can go to the YouTube channel, you can go to the LIGO India website and also check out the blogs. So there are many different things. There are podcast interviews, there are interviews of women working in this field. There are even events like if you take astrophotographs, you can even participate in the contests that are happening. There are behind the scenes interviews, like wherever there are gravitational wave discoveries, we interview the young researchers who are working on them, so you can listen to their interviews. And there are even different opportunities where you can participate in contests like science, art contests, and so on. Finally, yeah, so there are a lot of exciting things as well. So here you can see some of our young researchers. They are giving a virtual tour of the LIGO Livingston, the US observatory, and this is in Marathi. So go check out these videos on YouTube. So they are all available. If you want to read about LIGO detectors and gravitational waves, also the LIGO magazine, which is from the US LIGO detectors. So they are also available and they are free. You can just go to ligo.org/magazine and read more about it. There are a lot of fun stories behind the scenes and discoveries. So you can discover all of this. So that's it. So here I end with a photo of me when I was visiting the LIGO Livingston laboratory. You can see one of these arms behind me. This is the plaque which shows the first detection that brought the Nobel Prize. So here that marks it. And these are these giant detectors and these mirrors which are there inside, and also these beam tubes and so on, so the control room. So I had some fun, although I'm a theoretical physicist, but I had some fun checking out all these different things at the LIGO labs. So that's it, and I'm happy to take questions. Thank you for listening to me. Yes, yes. Yeah.
But when we went there today, they were telling us that it can discover from 15 megahertz to 1500 megahertz.
Yeah, actually, we are talking about two different things. So when you're talking about nanohertz, so you're talking about the radio frequencies. Okay, and what I'm talking about is gravitational wave hum in the background. Okay, so what they do is when they observe, so these pulsars which are going around, for example, so these pulsars when they are rotating at a certain frequency, radio frequencies, which they observe, okay? So these are what you're talking about. But what I'm saying is, like, for example, radio, when you turn on the radio, you hear music and whatever, but there is also a background noise. When you don't catch a radio station, you'll hear this background noise, right? So there is always this background hum in the universe. And that is what they detected as well. Yeah, and that is very low frequency, nanohertz. Yeah, there is a, yeah. Yeah, actually I can show this again. It's called an interferometer. So LIGO stands for Laser Interferometer Gravitational Observatory. So this is actually, so I told you about these two arms, right? So here you can see that a little bit if this video plays. So these are the two arms, and there is a laser pointer which sends light across the two beams. They get reflected from the mirrors and they come back here and form a pattern. And whenever gravitational waves pass through them, they actually change this pattern. Okay? So gravitational waves have a certain property, like if you have like a ring of particles, it's going to move, stretch and squeeze like space-time. So that can be detected. And from that, scientists can infer what was the object. Yeah. Yes. Yeah. Mhm. How do the black holes find each other? So, like, there are many black holes in the galaxy. So they could be formed from anything. Maybe they were born during the birth of the universe. These are very small black holes. Then you can have stars dying, like the one I was showing you earlier. So when stars die, they can also form black holes. Like in this picture, like when stars don't have any more fuel to burn inside, they can also form a black hole. So all of these black holes are there, and they can collide. Like when they come closer to each other, they can collide, and that's what we are observing. Yeah.
Okay, sorry for being the villain. I'm sure they want to listen to you and ask you more questions. So this was an amazing, amazing display of deep scholarship with the public spirit of sharing, which is very, very amazing. And I'm sure you may secretly be believing that outreach is the easiest part of your job. So please do interact with Dr. Chatterjee as you find more time. And in the interest of time, I'm sorry we have to stop some questions here, but I'm sure the kids will find you right here. Thank you so very much. She deserves a big round of applause.
Thank you, thank you. Feel free to come up and talk to me later as well.
Most certainly. Okay, so I now would like to introduce our next speaker, Sonal Thorve. Sonal Thorve is an astronomer, STEAM educator, science writer, and independent researcher whose work brings together education, science, communication, and experiential learning. Since 2004, she has been creating learning experiences that encourage curiosity, critical thinking, and meaningful engagement with science across classrooms, teacher education programs, and public outreach initiatives. Professionally, Sonal has contributed to teacher development, educational research, science outreach through her work with ZenWorks Solutions, Pimpri Chintwad Science Park and Planetarium, IISER Pune, and IUCAA. She has designed and facilitated teacher development programs across several states in India, supporting educators in strengthening science and mathematics learning through inquiry and reflective practice. Over to you, Sonal.
Thank you so much. So it's a pleasure to be here to interact with you all champions over here. Till now we have heard from the experts about astrobiology, the circadian rhythms, and everything that runs our body clock. And then we also heard about black holes and how we detected black holes, right? Now, I am just going to take you all a little towards Earth. Okay, we have been into space now. We have seen those amazing things and how those are detected, how we observe all those fascinating neutron stars, black holes, and whatnot, and how space works, like the web and all, right? So we try to visualize things, right? Now let me take you back to Earth, to something basic. You may find these questions very basic, but I will reveal the answers later. Okay, why these are important. I would like to know that since all of you are here champions from the astronomy quiz, right? We have taken the astronomy challenge and everything, and you are all here because you outperformed, right? Now, I would like to know how many of you have observed what actually happens in the sky. Any event, any object, which is your favorite. Okay, feel free to tell. Yes? Mhm. Okay. Mhm. Very nice, very nice. What's your name? Atharva. So Atharva observed one particular star. And why did you choose that? Okay. Okay, very nice, Atharva. Thank you. Nice. Very good, very good. So, did you hear what he said? He tried to be friend with that star. Okay, and that's what is very important. If any one of you is willing to be in astronomy in future, okay. So, if you want to be astronomer, astrophysicist, astrobiologist, okay, or if you want to do anything, any research, any studies about the objects in the space, in the universe. This is very important. Being friends with stars. Okay. Yes. Thank you, Atharva. Yeah. Hmm? Ah. Yes. Okay. Very nice. What is your name? Pavika. So Pavika observed blue moon. Pavika, can I ask you, was it blue? It wasn't blue, right? Why? Right. Send out the blue light, right? Yes. Yes. Very good, Pavika. Thank you so much. So, why do we call blue moon? The blue moon. Blue moon. Yes? Hmm. Okay. Okay. Very good try. Uh, yes? Ah, okay, she is closer. Okay, so it is actually the second full moon of the same month. Okay, how many of you have heard about the phrase once in a blue moon? If we don't meet often our friends, like we stay in the same city, and still I think Debarati and we are meeting once in a blue moon right now. Okay, so once in a blue moon means a rare event, right? And it happens when full moon occurs twice in the same month. And as you mentioned, it was on 31st May. It means on 1st May there had first full moon of the month. Okay, very good, Pavika. Thank you. Anyone else? Any other event, object? Yes? Shooting stars, very nice. And what did you feel? Very nice. Kush, right? Yeah, thank you, Kush. Yes? Yes, that's my personal favorite. Many of us actually. Yes, your name? Advay. Okay, thank you, Advay. So you have seen meteor showers, you have seen eclipses, then one particular star. And let me tell you why Sirius might have caught your attention is because it is the brightest star in the night sky. Yes, yes, and yes. So when I was like your age, or maybe younger, I used to look at it and I used to call it diamond because at that age I didn't know that star's name or anything, but I just knew that there is something that sparkles like a diamond in the sky. That was serious. Okay, so yeah, blue moon, meteor shower, shooting stars are nothing but meteors, right? So in scientific terms, we call shooting stars a meteor. Earlier, people did not know what meteors are, right? And it just looks like a light, a streak of light, which sparkles for a fraction of a second and then vanishes. It looks like a star. So it's shooting star, it became shooting star, a very fascinating object. And Geminids is the king of meteor showers. I personally have experienced one Geminid in, I don't remember, a few years ago, maybe in 2018 or something, 18 or 19. I observed more than 300 meteors. Imagine this. More than 300 meteors, more than 300 shooting stars. I personally counted. Okay. Yes, I counted in 3.5 hours of the night. But for that, I had to go away from the city. Like Atharva mentioned earlier, that they live in an area which is industrial, so only bright stars can be seen maybe, right? So fainter stars might not be visible. So you can only see the bright objects. If we go away from the city, if we go away where there is less light scattered in the space, less light scattered in the sky, you will be able to see many more stars. Okay. Now tell me, how many of you have seen the dark skies with many number of stars than we see through city? Okay, very good. But very few of you, less than 50%. Okay, so I would request everyone who have not been there, please find one day out as a picnic and and go out towards some village, okay, nearby, and look at the stars. You will actually find directly the number has gone 10 times higher. So you can count the stars. Okay, through city lights, we can, throughout the night, we can actually see around 270 to 300 stars. Okay, but if you go away from the cities where there is less light pollution, okay, so there you can actually find out 3,000 stars. You can count them. Okay. So that is the huge difference the light pollution makes. And now I am talking about something which is very important here, light pollution. Okay. How many of you have heard this term, light pollution? Okay. Yes, all the champions have heard it. Okay, can anyone tell me what is light pollution? Maybe you? Huh? Hmm? Yes. Okay, okay, Advait, thank you. Anyone else wants to add anything? Yes. Ah, excessive use of man-made lights, yes. Mm-hmm. Right. Right, right. So everyone is correct. Okay. So light pollution is simply unwanted light scattered in the sky. It is unwanted. Okay. So the light we want is only supposed to focus on the roads where we can see, right, are visibly like the range where we want to keep our eyes on while driving, while walking, while running. Okay, we don't need the light around the bulbs that is going in the sky. Okay, and you must have seen those halos around each street light. Have you? Okay, so that is what is light pollution. Okay, the unwanted scattered light. So if that light pollution goes away, what would happen? There is one famous story about it, and it has happened in reality in 1994. Many of you were not even born, your parents might have born that time. Okay, so in 1994, there was a major earthquake in Los Angeles. Okay, in LA, and due to that earthquake, the early morning earthquake, power outage happened. Okay, and due to that power outage, many people got to come outside their homes, and some of them actually called 911 to report that there is something mysterious, silvery, cloud like object in the sky, and we don't know what it is, so we are afraid of it. That was Milky Way. So the beautiful photos Devarati showed us, right? So that kind of object people saw, but they never knew that Milky Way looks like that. So if any one of you have not observed it, please go and watch it. Okay. So that was Milky Way, and that is how much light pollution affects us. So now since we are talking about seeing things, okay, and observing events, how many senses we have got? 5. Which are those? Yes, can you name? Smell. Okay, can we use smell when we are studying astronomy? No. Then? Okay. Hearing. Okay. Auditory sense. Can we use it? Now yes. Now yes. Because Professor Devrati just told us that we are converting something in sound. But that is we are converting it. Can we hear it? No, we are converting those frequencies in sound. Like all of our mobile phones are working, we must have been getting some messages, phone calls in the background, even if the phones are on silent mode, right? Those communications are taking place in the radio and microwave radiation, that part of light. So there is light. Only when you are going to connect the phone, then only you are going to hear the sound. So we are converting the transmitters and receivers which are in there, that device, those are going to convert those radiation in sound, okay? And that is why we can hear those. And that is how we, right? So we converted that gravitational waves in the sound waves, okay? So hearing also is not possible. Then touch. Can we touch anything except earth? No, right? Then taste. Taste we cannot do, of course, right? So what remains is sight only. So we are kind of restricted to use only one sense, sight. And that is why I started asking you with what all things we have seen or observed, right? We are restricted to use that only one sense. Okay. And using that, you can actually see amazing things. You can calculate the motion of the moon, calculate the motion of planets on your own. Like Sir mentioned, that if you don't use your brains, okay, if you don't, actually that was my fear too. When I was developing the curriculum to teach AI, to teach us. So I was like, everyone is using AI to ask any question, any basic question, and they were feeling themselves, even if they are very experienced teachers, they were feeling less confident to say that this is wrong. They were saying, am I wrong? Even if they have learned that rotation means parivalan. Still, they were asking a question, AI told me this. And that time I was actually afraid ki will that day come when all those brain muscles will stop working and brain becomes a vestigial organ. So that was my fear. I hope it doesn't come true. Yeah. So when we observe things, we can actually calculate everything that Galileo had done, Kepler had done, okay, what Einstein has done. So, how many of you like to observe things? Actually, not only theoretically, but want to see, calculate how it works, how moon takes this much amount of time to go around the earth. Why they say, or Google says, that moon takes only 27 and a half days to rotate around, revolve around earth, but there are 29 to 30 days gap in between two full moons. Why? How many of you have tried to calculate it? You have done it? You have done it? Okay, how did you do it? Hmm. Hmm. Okay, okay, good. Thank you. Your name? Dev. Okay, thank you, Dev. Yes, Atharva? Hmm? Ah, very nice. The time it takes, yes, yes. Right, right. So, Atharva, can you please join me in one demo? Can you please come forward? I would like one more volunteer here. Anyone? Okay, let us call someone who has not said anything yet. Is there anyone? There are many actually. Can you? Yes, please. Okay. Atharva, you are going to be moon and Leoma. Leoma is going to be earth. Okay. Now, we know that earth rotates around itself and revolves around sun, right? There are two major motions of earth, right? So, Leoma, can you just show us what rotation means? You have to show us, not tell us. Very good, very good. Now consider me as sun because I am wearing yellow. Nothing else. Show me what revolution means. Okay, good. Thank you. So everyone got this? Rotation is rotating around itself, spinning around your own axis. And revolution means going around other object. Now, moon. Do you rotate and revolve both? Okay. Now, let us take these two and see why there is this 2.5 days gap in between the time period of actual rotation period and revolution period of the moon and the distance between two similar phases of moon. Okay. Now, while moon, can you just go around the earth? Leoma, you can just step forward so that he will get, yes, very good. Now, while that has happened, till the moon is completing one cycle, okay, one revolution, the earth is also have revolved a bit around sun. So Leoma, can you please move here? Now see, the moon was supposed to be here, but it is not. The moon is here only, a few phases back. It has to come here again, okay, to be in the same phase as it started a month earlier. So that is 2.5 days gap we get. Okay? Yes, thank you, Leoma and Atharva. Yes? Yes. Yes, yes. Yes, you're right. So do you want to demonstrate that? How it happens? And then we'll end and take some questions. Okay? Can you come forward, Advai? Can you come forward, please? Yes. Let us see. Hmm? 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 Yes. Okay. Yes. At the same time. Huh. So now, while you have rotated around me, revolved around me, okay, and that at the same time you have rotated also. Rotations means now you may get confused because he is revolving, but at the same time he was also facing me all the time or facing earth all the time. And that sometimes get misunderstood as moon does not rotate because we can see the same face of the moon all the time. But actually in space, what moon did was, moon actually faced this, in the next phase moon was looking towards some other direction. So moon was changing its angle through the space. Rotation is that only. Right? Huh. Exactly, exactly. Very good, Advai. Okay, so claps for Advai. Very good. Now, come here. So, let us start rotation and revolution. Now I am not sun, I am earth. Okay. Now as Advai said, moon is going to rotate as well as revolve in 27 days. Okay, let us take a round figure. Let us not consider that half part. So now please come forward. I have moved forward. Okay. Now, if you calculate the 360-degree around the earth in 27 days, you will actually find out how many degrees in space around earth the moon has gone. Huh. But it's a very simple mathematics. You can actually do it. 360 divided by 27. Okay. So whatever number will come, you will find that in 2 days, the earth has actually moved 2 degrees around the sun. 2 degrees around the sun. So that 2 degrees extra, okay, moon has to cover to get into the same position in space. And that adds up 2 days. Okay? Do that calculation and let me know. Not now, not now. Aram se. Hmm?
So 20, there would be remainder of 9 days.
Yeah. 9 days? Don't think in days. Right now, let us just talk about 360 divided by 27. That will be degrees in per day. The moon will have moved that many degrees in space per day. Has anyone done this 360 by 27? 13.33. Yes, something nearby 13.3. Yeah, right? Right. And in the 2 days, Earth has also moved. Okay, so the moon never completes that phase. So it takes that 2.5 days more. Okay, to cover that distance. Okay, thank you, Advay. So did that answer your question? Okay, so I'm going to stop there, but if you have any questions, I think we can take on 2 questions and then, yeah. Huh? One? Acha, 2 questions, yeah. Yes? Okay, so it's a very nice question. I do not know the answer exactly, but naturally it has been there. It is also called as tidal locking. Okay, tidal locking means the object that revolves around something, the rotation period of that object is also the same. Okay, so the term is called as tidal locking. I really do not know the answer. It is naturally there, and many of, not many, but there are other objects too which are tidally locked with their companion objects. Okay, thank you. Yes, Atharva? Just same question it was. Okay. Mercury. Okay. Okay, so nice. Thank you, Tusharda. So Mercury is tidally locked with the sun. So if we go to not Mercury, on the sun. Okay, if we go towards the sun on that side of the Mercury, so Mercury, you will see the same face of Mercury all the time. Okay. Any other question? Last question. Okay, so we can talk later also. We are going to be there. Thank you very much.
Thank you, Sonal. I'm sure we would have wanted it to continue for as long, but some parents have to fly out later today, and we will need to definitely move it as quickly. Key takeaway from this is remain awake, and no matter what happens to your other senses, keep your eyes open. That is the big takeaway. And you can imagine, any one of you, how would Aryabhatta would have calculated, the 365 days and few hours. Can you imagine the kind of observation and the kind of effort that it would have taken? I'm sure he would have remained awake, was suggested here. All right, so we have, the last speaker of the day, and we are requesting, him to move as fast, though he was, the first to come in, but that is the sacrifice, that we request today. Tushar Purohit is an observational astronomer and has decades of experience working as an astronomy resource educator. He has been working in TMT India and LIGO India outreach team of IUCAA Pune. At IUCAA, he has been conducting telescope making activities since 2012. We would like to call him the telescope man of India. Conducts workshop and programs in various institutes like IIT, IISER, IIST, planetariums and universities across India since 2000. He has conducted hands-on astronomy activities for Inspire Camp since 2009 and conducted more than 112 Newtonian telescope making workshops, and guided in making more than 6,000 telescopes. He has been a master resource person at Vigyan Prasar, New Delhi since 2014, where he conducted more than 65 training courses for teachers for various schools and tribal teachers. He has guided more than 1,000 Akash Darshan sky watching programs and more than 65 workshops since 1995. And I'm already impressed, by his patience. So over to you.
Thank you. And basically, thank you for Mila Mitra and Gautam for inviting here. Basically, I will not talk more about this right now. Tomorrow, you are going to visit to Ayuka. So, Ayuka, where you can talk about many more things about the astronomy, and you can see the campus the campus is a full with astronomy. So, we'll see you tomorrow. All right. Thank you. Ayuka.
I'm reminded brevity is the soul of wit. Thank you very much. I really appreciate it. And now the big event for which you are all here. May I invite Sure. Yeah. So the big event that you're waiting for, and for this first, may I invite our guests of honor to be here on the stage, Dr. Nath and Dr. Debarti. Please be on the stage, and may I request Suvriti to hand over a small token from our side. Or will Dr. Mitra do it if Gautam is? Okay, Suvriti is right here. And right after that, Suvriti will also take over. So we would like you to, remain here to, give the awards to the students. But before that, Suvriti, if you could kindly honor our guests with a small token of gratitude that we bring. I hope you are able to hear me. Yeah, okay. Yeah, Suvriti. Thank you very much. May I now request Sonal and Tushar also to be here? And Suvriti, if you could, please do the honors. You please stay there because you could keep it there. Yeah, sure. Come. Yeah, Suvriti, please do the honors for Tushar. Thank you, sir. And to Sonal. Thank you. As many. Okay, Sonal and Tushar, you could, come back and join us in a moment for the word, and please be at the center stage, both of you. Yeah, and
yeah, on the top of the dais, please.
okay, over to you.
Thank you so much, sir. So, once again, thank you so much to our guest of honors for enlightening us about their experience, about their knowledge, about few things that many of the kids actually, got to know. So this is the platform where you actually get an exposure to such kind of people. This is a platform. It's not just about learning. Probably most of you might not have understood even 90% of the work that Dr. Debarati is actually doing, because. Yeah, but what was important is that they get inspired by the work that you have done. So when they go down the line, 2, 3, 5 years from now, that's where they will be actually able to correlate the work, right? So anyway, with that, thank you once again so much, and I'm sure that all of you are long awaiting for this moment when we are finally, conducting the award felicitation ceremony for our National Astronomy Challenge 2025 to 26. So first of all, I would like to thank all of you, along with all the participants and people who are watching us live, for joining us live, tuning in today, and also showing their enthusiastic and exciting participation in our National Astronomy Challenge. It was indeed a very tough, indeed a challenge for all of us also to select the winners. when we had actually declared. It took quite a lot of time, and also we had to go through a lot of parameters to finally bring up the people who are sitting with us right now. So once again, congratulations, first of all, to all the winners of this National Astronomy Challenge. So now, since all the winners who are here were in the previous grade when they actually appeared for NAC, and now they are promoted to the next grade, I'm not going to call up the grades. Instead, I'm going to call up the student along with the name of the school from where they are coming from, along with the city. So as you are already aware, we have Dr. Devrati ma'am and we have Dr. Bimalendu sir, who will be here to felicitate some of the winners who we have today. So let's begin the award felicitation ceremony, people, with the first, and this is of course not based on rank, this is just based on a random list that has been handed over to me. So please do not go haywire on if your name is coming towards the tail end. It does not reflect your rank, okay? All people who are here are the winners. So let's begin with, first of all, R. Prithvi from DAV Public School, Chennai. And there's some kind of magic potion which DAV Public School Chennai is giving to its student, because here DAV Public School is collecting this award in NSC for the 7th time right now, participating in 7 years this time. So congratulations to Prithvi, and congratulations to DAV Public School as well. So sir, I please request you to please do the honors to the student as well as the representative teacher from DAV Public School. So while we are having the photographs with Prithvi, let me call up the next person. The next winner is Unnat Vora from Amity International School, Saket, New Delhi. And once again, we have Amity International School who is collecting this award again, 3rd time. That means participated 3 years in a row. So yes, Unnat, please come up on the stage. So people, please welcome the winners with a big round of applause. It's indeed a very big achievement for these young people. As you can see, almost half of most of our height, but still having the passion and curiosity for astronomy and space science, probably more than what we have combined. So we wish the best luck and also the best for the future endeavors as well. So here we have Unnat Vora from Amity International School, Saket. So please give a big round of applause for him. And we have the representative teacher as well. The next winner who we have is Ashita Agarwal from Darbari DAV Model School, New Delhi. And once again, Darbari DAV Model School collecting, once again participating in NSC for 7 years now. So almost all the campaigns, ma'am, I believe. So please welcome Ashita on the dais with a big round of applause. Ma'am, you as well. So then we have Akshara V from CS Academy, Trichy Road Campus, Coimbatore. And CS Academy, Coimbatore is again collecting this award again as 3 years. So congratulations to CS Academy as well, and congratulations to Akshara. So please give a big round of applause, people. So we'll get some nice applaud emojis after we have the dinner, I believe, circulating all over the social media on statuses. Thank you so much. Next up, we have Advait Manish Sharma from Billabong High International School, Mumbai. So Advait, I request you to please come up on the dais, and I think we have Advait's parent, who is also here. So sir, I please request you to come up on the dais and collect the award for Billabong High International School on their behalf. So please give a big round of applause for Advait. So photograph. Next up, we have Hiya Pavish from Cyborg School, Thaliparamba, Kannur. And I believe Hiya Pavish was probably not able to attend this ceremony right now. So, so on behalf of Hiya Pavish, I believe, yes, ma'am, please. So, please welcome ma'am, who is going to collect the award on behalf of Hiya Pavish from Cyborg School, Kannur. So now I would like to welcome Adrit Vipin Das from Indian High Group of Schools, Dubai. Once again, I believe Adrit was probably not able to make into the ceremony. So, ma'am, I request you to please collect the award on his behalf as well. Then we have Pavika Grover from AMNS International School, Surat. And AMNS International School, Surat. And Pavika, again, participating in NAC for the second time now. So please give a big round of applause for Pavika now. And congratulations to AMNS International School, Surat for participating 6 years in a row in our National Astronomy Challenge.
I'm told there is a surprise reward for the one who claps the most and most audible.
Then we have Advait Preetam Bhosle from 21K School, Panvel, who is the next winner. And once again, this is the third time that he has participated in the National Astronomy Challenge. So he has won the third time as well, not only a participant. So single-handedly taking up 21K School, Panvel as a one-man army. Advait Bhosle over here. So please give a big round of applause for him. Next up, we have Nainika Buddha Reddy Gari from National Public School, Bangalore. And National Public School, Bangalore, once again, participating for 2 years now. So ma'am, I request you to come up on the dais as well. So please welcome Nainika with a big round of applause as well. Then we have Sharath Rajesh from Koppel Middle School East, coming all the way from Dallas, Texas, USA. Probably traveling one of the longest distances in our entire auditorium right now. So please give a big round of applause for Sharath. Again, as an individual winner from Koppel Middle School East, Dallas, Texas. Then we have Dakshita Barika from Darbari DAV Model School, New Delhi, once again. So as I've told earlier, Darbari DAV Model School, New Delhi is definitely doing some magic potion towards students, collecting awards for 7 years now in a row under National Astronomy Challenge.
So I request Sonal and Tushar also to be on stage for distributing the awards. You please continue to be there. Please join us. Thank you. The award is for real, so keep the clappings going on.
So then we have for third time in a row. So congratulations, Ravanshi, and people, please give a big round of applause for such kind of talent. Please. So I'm one of those people who actually works upon the questions in NAC, and I think I will need to do much harder work this year because I'm getting repeated winners now. So ma'am, we need to get back to our dictionaries. But congratulations once again, people. Next up, we have Sasha from Delhi Public School East, Bangalore. And Delhi Public School East, Bangalore taking up the prize in NSC for second time now. So the round of applause should be continued for Sasha from DPS East Bangalore. Next we have Arnav Sangal from GD Goenka School, Muzaffarnagar. And Arnav, request you to come up on dais to collect your award. Being the the first time winner from GD Goenka School, and he is also collecting the school award on their behalf. So Arnav once again taking up his school single-handedly like a one-man army. So congratulations, Arnav. Next up, we have Atharv Jindal from ASPM Scottish School, Noida. So please give a big round of applause for Atharv Jindal. And Atharv once again, congratulations. The next winner is Raj Rishi Nanda from Delhi Public School, Raipur. And both Raj Rishi and DPS Raipur taking up the reward in NAC for the third time now. So congratulations, Raj Rishi. It's a hat trick for him now. Yes, sure, ma'am, absolutely. So since it has been a streak of awards now for some time, how about we take a couple of minutes of break? And ma'am, I please request you to speak a few words on this occasion.
Honorable dignitaries, Dr. Mila Mitra, and the entire team of STEM and Space, teachers, and parents, and all dear students, champions of National Astronomy Challenge. First of all, I would like to congratulate all the national champions of NAC. So let us give them a big round of applause. I, on behalf of Delhi Public School, Raipur, would like to extend our heartfelt gratitude to STEM and Space for such a wonderful arrangement they have made, making the visits for various places possible, like big institutions like ISRO, remote sensing satellite centers, then now GMRT, and this IUCA. So I would like to say that it was really a wonderful experience, and our students, that was a great experience for our students, and they, with every visit, with every interaction with the scientists, astronomers, you lit the spark in our students. And that changed, that turned their curiosity into learning, and changed their curiosity into, and that changed their curiosity into questions, and the questions into learning, and learning into dreams. So you have given a big platform for them, so that they could dream big and pursue science with passion, and pursue science with passion. So thank you once again, STEM and space team. And I would specially mention their warm hospitalities they have rendered to us, whether it is their meticulous way of stay arrangement, travel and stay arrangements they have made, which enable us to, for this wonderful, so that we could enjoy our day and make our day a memorable one. So thank you once again for this wonderful experience, and thank you so much.
Thank you so much, ma'am, for your kind words, and appreciate the compliments that you have given to us. On behalf of STEM and Space, I would like to really thank ma'am and all other dignitaries that are here together with us. So moving on, the next winner of our NAC 2025-26 is Dev Todi from NL Dalmia High School, Thane, Mumbai. Again, both Dev and NL Dalmia High School taking up the award second time now. So please give a big round of applause for both Dev and NL Dalmia High School, Mumbai. Now we have Anvita Sahu from Vikas First Step, Sambalpur, Odisha, who is going to collect the reward for her being the winner in NAC. So congratulations, Anvita, and as your school name suggests, Vikas First Step, so this is your first step as a winner in NAC. So we hope you take further second, third, and eventual more steps towards the future NAC challenges. Next up, we have Chahat Hirani from the Indian High School, Dubai. So again, on behalf of Chahat, I request ma'am to collect the reward, and Indian High School, Dubai, once again, collecting the rewards for 6 years now under National Astronomy Challenge. Next up, we have Kush Kumawat from Cambridge Court High School, Jaipur, along with Deepika Mina from Cambridge Court High School, Jaipur itself. So both participants from Cambridge Court High School, Jaipur. Again, the school taking up the reward for 2 years now under National Astronomy Challenge. So invite both the participants and their representative teacher to collect their reward. Please give a big round of applause for the participants as well as the school. Next up, we have Rudra Minar Khatu from Indian School Al Wadi Al Kabir, Muscat, Oman. And Indian School Muscat is now collecting the award for 4 years now under National Astronomy Challenge. And thank you so much, Indian School Muscat, for repeatedly participating in another one of our flagship programs that is called IASC, that is the International Asteroid Search Campaign. So we have had repetitive participations from many other schools as well, of course, including Indian School Muscat, Oman. So Rudra, your school has won four times. We hope to see you again winning the NAC under your school itself. Then we have Leoma Mahato from Delhi Public School, Faridabad, who is again the winner of NAC for the first time. Congratulations, Leoma, and congratulations, ma'am. And we hope that you take up even more prizes in future under National Astronomy Challenge. Then we have Tasmay Jain from Vidya Shilp Academy, Bangalore. Tasmay winning National Astronomy Challenge for the second time now, and Vidya Shilp Academy, Bangalore collecting the reward on behalf of their students for 6 years now under National Astronomy Challenge. So please give a big round of applause for Tasmay and Vidya Shilp Academy, Bangalore. And finally, we have Rudra Shri Bojraj from CS Academy, Coimbatore, who is again the winner of National Astronomy Challenge. CS Academy, Coimbatore, collecting the award for 6 years in a row under National Astronomy Challenge. So congratulations to CS Academy, Coimbatore as well. So please give a big round of applause once again, people. So it was quite an exhaustive list, despite having a tough competitive exam, and we didn't have any paper leak either. So, still got an array of winners. So once again, please give a big round of applause for all the winners of National Astronomy Challenge 2025 to 26. Thank you all so much for participating, and we look forward to your active participation even in our future campaigns. So, now, of course, before we conclude, there are a few schools as well who have performed really well, and their constant active promotion of their students as well as encouragement in participation in such kind of competitions has held them really high in regards when it comes to the entire academia. So I would request Honorable CSP sir, request you to just come up on the dais and announce the rewards for the schools who have repeatedly given great winners in National Astronomy Challenge.
Thank you, Randeep. The first school that I would like to announce is Orchids, the International School. Congratulations. So I must tell that, it all starts in the school, and when you ignite the, flame, we strive to continue it and make it a fire. Thank you so very much. The next school that I have is Meteor Shower Maoist, if I have announced it correctly. Okay. So. Okay, so it's the Indian High School, Dubai. Indian High School, Dubai. Wow. So you have been the busiest person today. Thank you. Thank you so much. Four, and that this is fifth, right? Acha, this is including this four? Okay. So maybe six next time, if you like cricket. Okay. So the next one is Greenwood High, and the award is Astronomy Pioneer Plaque. Greenwood High. Wow. New school with maximum participation. Lovely. Thank you so much. Okay, all right, okay, yeah. Thank you, thank you, thank you so much. Thank you, for really stretching your day and time and maintaining the high spirit of giving for our champions. Surely, surely.
Okay, sorry, I'm just taking 2 minutes of your time. Yes, yes, yes. So, I would like to mention something that has been going on for long on my mind, and finally, one of my dreams have also come true. So, I think it is the right platform to share that. I published my first children's astronomy book this Sunday on the occasion of Professor Jayan Narlikar's birth anniversary on 19 July this year. So I published this book, and why I'm sharing it over here is because it is written specifically for the age group of 8 years to 15 years. Okay, and the book's name is A Million Questions, A Billion Stars. So you can check it on Amazon.com. People who are from Dubai to your marketplace. So Amazon.in is not working. For Indians, I have specifically circulated other form so that I will share the author copies with them. Okay, so thank you very much. And I would also like to thank everyone on behalf of all of us over here. Thank you for inviting us, and thank you.
Thank you, and many congratulations. I'm sure many of us would like to, buy your book. Okay, so all good things must come to an end. So would be this evening, but the spirit should remain aflame, remain high. And you are a young explorer of the cosmos, and today's stargazers are the ones who will walk on new worlds tomorrow, definitely even outside of the Earth planet. I would now like to propose the vote of thanks before we end this wonderful ceremony where I know you have had a very, very long day. You started very early in the morning, and the way you are maintaining your spirits, definitely tells us that, the youngsters are definitely going to, be the real stars who would make an impact and make our country proud. Respected guests, guest of honors, our speakers, teachers, principals, parents, students, and friends. It has been a privilege to hear so much wisdom, passion, and encouragement tonight. On behalf of STEM in Space and the National Astronomy Challenge, I offer our heartfelt thanks. Thank you, Dr. Debarati. Thank you, Dr. Bimlendu, for your inspiring and insightful talks that reminded us why science needs courage, clarity, and care. You must, go to the hill at 2 a.m. If you love it, give everything that you have to give. That is the only way. There is no other way. It definitely is a very, very hard work that is required, and you exemplified it. Thank you, Dr. Mila Mitra, for sharing the vision of STEM in space and for guiding young minds toward the skies. A special thanks to our distinguished educators and practitioners, Sonal and Tushar, for your practical wisdom and decades of work in teacher development, telescope making, and public outreach. Your efforts light the path from curiosity to discovery. To our award presenters and coordinators, Subriti and Ranadeep, for announcing not just the winners, but seamlessly tying the event. And thank you for making the felicitation meaningful and smooth. I also wish to thank our internal team, whose names you know so very well. Gautam, who's right here with you. Hema, Suvriti, Ranadeep, Suparna, Deepak, Garvit, Dimple, and every other member behind the scenes. For months of planning and late nights and flawless execution, this event reflects your commitment. Thank you very much for giving them a round of applause, which I think perhaps can go on for at least a minute if you would like to. Thank you. My deep gratitude goes to all the teachers and principals and seniors present here from across the countries who nurture students' interest in astronomy and encourage them to ask bold questions. Thank you to the management and staff of Panchratna Hotel for your warm hospitality and excellent support. And most importantly, to our participants, young astronomers, you are our real stars. Keep questioning, experimenting, and looking up. The future of science belongs to your curiosity. Once again, thank you to everyone who made this evening possible. Please join us for dinner, and I wish safe journeys to those who are leaving tonight and to others who would be leaving tomorrow. Please be with the presenters and speakers with any of your questions, and thank you very much. Good evening once again.
Sir, could you please announce once we'll take a nice group photo with all the winners with their rewards on the stage?
Okay. And would it be nice for all the awardees to come on stage for a group picture?
Please carry your awards as well.
And I also am told that some of the participants have got some souvenirs, so you would like to give it to whoever, the presenters who were here or whoever you like, please feel free. Thank you. Thank you so much. Okay. Right after the students, we will also have the teachers coming up. So first it is the students.
That's what we've come here for.
मोबाइल फोन का अगर हो गया तो हम लोग ले लेते हैं some space. Dr. Mila Mitra and Dr. Chatterjee would like to sit with you. Yeah, go, go, go. And Afina, you know,
I'll go on the other side.
yeah.
Just take a minute, sorry for that. Now you should.
Thank you. Thank you. And now the teachers, please. All the teachers.
Please.
And the speakers remain here.
Yeah, yeah.
Thank you so much. Thank you. See you soon. Bye bye. Take care. Take care. And to relax कर थोड़ा सा. Relax नहीं.
Gautam, you come in.
Come, come.
Should we take half the teachers and then
Some of us again can sit, I think.
yeah, let's stand in a curve like we'll see.
Yeah, that makes sense. Thank you.
Okay, okay, everyone. Thank you, everyone.
Thank you so much. I think dinner is also ready now.
Yesterday I saw a peacock.